We've talked about the inverse trigonometric functions from a purely functional perspective, but it's also important to understand them from the geometric perspective of right triangles. The inverse function attempts to answer the question, given an output value, what input value could it have come from? We can reinterpret this question specifically for trigonometry by asking, given a trigonometric function, what triangle could it have come from? This makes the most sense by working through an example. Example: use a triangle to represent the inverse cosine of 3/5. What triangle can we draw so that the cosine of some angle is 3/5? Let's just look at a generic right triangle, and let's let theta represent the unknown angle. Since the cosine of an angle is adjacent over hypotenuse, we could just label the adjacent side 3 and the hypotenuse 5. This gives us a perfectly valid representation of an angle theta such that cosine of theta is 3/5. But once we have this picture, we can then go further and compute the trigonometric functions of this angle. Recall that if we know two of the sides of a right triangle, we can use the Pythagorean theorem to calculate the length of the third side. Also, once we have all three sides of the triangle, we can compute any of the 6 trigonometric functions relative to the angle. Example: compute tangent of the inverse sine of 5/7. For notation, we will let theta equal the inverse sine of 5/7. In other words, theta is the angle such that sine of theta is 5/7. So we draw our generic triangle and label the sides accordingly. We now compute the length of the third side using the Pythagorean theorem. Tangent is opposite over adjacent, and so we have everything we need to complete the calculation. These calculations are actually old ideas that we've covered before, just put together in a brand new way. We've been working with the right triangle picture of the trigonometric functions for a while. The new approach is that instead of being given the triangle, we're creating it from given information. As we continue further into this class, we will keep returning back to these core ideas, but we'll continue to see them from new and different perspectives.